Good morning, friends. Today we are going to discuss TSPSC or TGPSC PCB Exam Paper 2 Chemistry, and today topic is oxidation states and oxidation number from our syllabus given by TGPSC. Okay, already three lessons are completed: atomic structure, classification of elements, chemical bonding. Once you check it out in my channel, and all are there with a clear explanation and very important questions are covered. Okay, don't forget to subscribe my channel. So today we are going to start this lesson with very important questions. Okay, yeah, see this. So topic is here oxidation states. Oxidation states here. Oxidation states with the oxidation number, right? Oxidation state with the oxidation numbers here, and reduction. What is oxidation? And common reduction reactions, ionic reactions, balancing equations, and oxidation and reduction reactions. Mostly it is based on oxidation states and oxidation number, reduction, and oxidation. So we'll see some important questions based on this. Okay, so don't forget subscribe my channel and don't forget to share to your friends those who are required PCB chemistry. Clear? So now we'll see one by one. What is the first question? See this TGPSC PCB Exam Paper 2 Chemistry Oxygen States Redox Reactions Ionic Equation. This is title is given by TGPSC. Clear? Based on this, I framed 20 important multiple choice questions with best explanations. Okay, all of you see this. First one, what is oxidation or oxidation process involving? Oxidation process involving what? Okay, so see this. Oxidation means what? Here we have three important concepts here based on the oxidations. I will explain first one. All of you concentrate. First one is addition of oxygen is called oxidation. Second one is removal of hydrogen also is called oxidation. Third important is third important is third important is here removal of electrons also called oxidation. So based on this, we can see that option here. First one is gain of electron is given. So this is not gain of electron. Loss of electron is there. Yes, this is loss of electron. So your answer is loss of electron. Gain of neutron is not, it is wrong. And no electron transfer, it is also wrong. So your answer is loss of electron is called oxidation. And addition of oxygen also called oxidation. And removal of hydrogen also called oxidation. Opposite is called what? Reduction. We'll see this one. Clear? Yeah. We'll go for next one. See, already we have explanation. Oxidation means loss of electrons. And one more, increasing of oxidation state. Increasing of oxidation state. For example, you can take zinc 0 to plus 2. So that is here zinc 0 to plus 2. Plus 2 means removal of electrons. How many electrons? 2 electrons are lost. This is called here what? Oxidation. Clear? So increasing of oxidants are also called what? Oxidation. Increasing of oxidation state is also called oxidation. Don't forget this. That is nothing but loss of electrons. Loss of electron. Clear, friend? Next one, we'll see what is reduction involves. So very basic questions these are. The opposite of this one. See, similarly, reduction means we have Roman number one is reduction means addition of hydrogen. Addition of hydrogen. Roman number two is removal of oxygen. Removal of oxygen. Opposite is addition of electrons. Addition of electrons. This is called what? Reduction process. Okay, don't forget. This is called what? Reduction process. Okay, see this. First one is gain of electron. Yes, this is your answer. So loss of electron, oxidation. Increasing oxygen number, oxidation. Formation of ion, this is not correct. So that is here. So here decreasing of oxygen should also called what? Decreasing of oxygen is also called what? Reduction. For example, you can take here Fe plus 3 is there. We can take here Fe plus 2. See this decreasing of oxygen state. Here, for example, I am giving here one example. For example, iron has 10 electron. You feel that. Anukundaam. 10 electrons ఉన్నాయి. Okay. Now we can remove 3 electrons. Remove 3 electrons. What will get here? 7 electrons are present. Now here also you can give, for example, 10 electrons. You feel that. Then how many electrons you can remove? 2 electrons. So how many are there here? 8 electrons. You can compare now Fe plus 2 to Fe, Fe plus 3 to plus 2. What happened here? Change. So that is 7 electron to 8 electron. That is nothing but addition of electron. Addition of electron is nothing but what? Reduction. This is a simple concept. So anywhere you have confusion, you can take like example, you can understand easily. That is called here decreasing of oxygen state. That is plus 3 to plus 2. Example, same example you can see. Copper plus 2 to and addition of 2 electron, copper 0. Clear? So that is copper plus 2 gains 2 electron converted to copper 0. So that is a concept about of reduction. Now we see oxidation number of sulfur. So spelling is wrong. So sulfur, see PHUR sulfur. Okay, sulfur in H2SO4. How to find oxidation state? Very easy. I will explain. H2SO4 we are taking. So sulfur, yes means sulfur. You can take logic. 6. S means 6 group it is. Which group it is? Sixth group. So its group number is 6. That means you can take your sulfur. You can draw here 6 bonds around the sulfur. How many oxygens are there? 4 oxygens are there. How many oxygens? 4 oxygens. Each oxygen, here we need to add one hydrogen. This side and one hydrogen. This side one. Remaining we can keep double bond here. Now you check it out here. Uh, Around the sulfur, how many bonds are there? 6 bonds are there. That is nothing but group. Sixth group. Now we can take here hydrogen valency plus 1. This hydrogen plus 1. Oxygen minus 2. This oxygen minus 2. This oxygen minus 2. We can take how many minus are there? Minus 6. How many plus are there? Plus 2. That is sulfur is X is equal to 0. Then X is equal to what? You tell me. Take how many oxygens are here? One more oxygen. So one more oxygen also we can add. Then totally is plus 2 minus 2 remains. So remaining is 6. That is equal to group number. So mostly sulfur oxygen is equal to group number. Therefore your answer is 6. Sulfur oxygen is 6. Like this we can find here. Hydrogen valency plus 1. Oxygen valency minus 2. So your answer is 6. Clear friends? This is the way to find oxygen state of any molecule given by this way. This way. Clear? So that is the important about this one. Now we'll go for next question. Oxygen state of Mn in MnO4, KMnO4. KMnO4 even same. Similarly, same thing. KMnO4. Here manganese are taking. This is X. Potassium plus 1. Oxygen minus 2. So you can take here plus 1. 4 into minus 2 is equal to 0. So that is X is equal to, see, this is plus 1. 4 to the minus 8 is equal to 0. So X is equal to plus 7. See here, manganese in this periodic table, it is a B group element actually. It is B group in a periodic table. That is here, manganese is seventh B group. Seventh B group, its oxygen is plus 7. Okay, don't forget this. That is simple logic. Now we'll go for here. So your answer is what? Plus 7 is answer. Okay. Now which of the following is oxidizing agent? Very important here. Oxidizing agent. So just now we can see here what is oxidation state and oxidizing agent, right? So any compound which has oxidizing agent means what is main reason? All of you concentrate here. Very important concept is. So be careful. What is meaning of oxidation state? I am taking here KMnO4. KMnO4. So it is a oxidizing agent because it accepts the electrons. So this is it causes oxidation state, another substance. Self undergo reduction. So that is therefore it is a strong oxidizing agent. Strong oxidizing agent. For example, you can take KMNO4, KMNO4, right? We can split it. K plus MnO4 minus, right? Now what happened here? KMNO4 plus 2, plus 1. Plus 1 means what is the oxygen of this one? Plus 7. Plus 7. Clear? So total oxygen of this one plus 7. So this plus 7, this is plus 1. So after splitting of these two ions, what happened here? It is undergo what? Reduction. So that is here. Nothing but here. Any compound is undergo reduction. 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 That is good oxidizing agent. Good oxidizing agent. Any compound undergo oxidation, oxidation, will explain, oxidation, any compound undergo oxidation, that is good reducing agent. Don't forget this. Very, very important. Okay, any compound which undergo reduction, that act as a good oxidizing agent. Any compound which undergo oxidation, that is a good reducing agent. Therefore, it undergo reduction, therefore it is a good oxidizing agent. That's it. Clear? Right. Which of the following is the reducing agent? Same opposite. Just now what you say. So zinc is a best reducing agent. Undergo oxidation. Just now we see Z, zinc lose 2 electrons and Zn plus 2, thus giving off 2 electrons. See what happened here? What happened here? Tell me what is the process? All of you concentrate here. What is the process? Now this zinc losing of electron. Losing of electron is nothing but what? Oxidation. So it undergo oxidation means this is a good reducing agent like this. Clear? Simple concept. Any compound which undergo oxidation, that compound is act as a good reducing agent. Okay. So it is undergo oxidation, reducing. Undergo reduction, oxidation. Simple. Clear? See here given explanation. Reducing agents donate electrons. Donate electron means what here? You can see it undergo what? Undergo what? See, losses electron and reduce another substance. Therefore, this is a good reducing agent. So the process is called what? Oxidation. Clear? So here loss of electron is called oxidation, students. Don't forget. Loss of electron is called what? Oxidation. So the oxidation process, but that agent is called reducing agent. Clear? Yeah. Oxidation number of KClO3 of potassium. So chlorine. So he is asking here oxidation number of chlorine in KClO3. Chlorine is asking. Yeah. You can take here generally potassium plus 1, oxygen minus 2. You get the answer. KClO3. Here potassium plus 1, oxygen minus 2. Oxygen minus 2. Yeah, go for this. X chlorine, X chlorine, potassium plus 1. How many oxygens? 3 oxygens. Minus 2 is equal to 0. So X is equal to, what do you get? Plus 1. Isn't it? That is here 2, 3, 2 is 6. Minus 6. So this plus 5 is the answer. Plus 5 is the answer. So that is chlorine undergo plus 5 oxidation state. Simple it is, easy. Now we'll go for in the reaction zinc plus copper sulfate gives rise zinc sulfate plus copper. Zinc undergo yes zinc 0 to plus 2 oxygen state. This is minus 2. So what happened? Zinc plus 2 to zinc 2 zinc plus 2. What is this? Tell me all of you. What is this? Yes, comment on this. Say a loss of electron, isn't it? So it loses 2 electron. So they undergo oxidation. Undergo what? Oxidation. So the process is called what? Oxidation. Very easy it is. You can write like this, we will get the answer. Okay. So now a redox reaction involves. This is very important. Redox means it undergo reduction and oxidation both. A redox name itself is giving redox, reduction and oxidation. Redox means reduction and oxidation. Both are there. Reduction and oxidation. Both are involving. Therefore, the type of reaction is called reduction reaction. reduction reaction. All of you see this. Where is the option? Both oxidation and both oxidation and reduction. Where is the option? Option C is correct. Right? That is. Next one. Which of the following ion is which ion is reduced in? Reduced in. Which is reduced in? See this. Which is reduced? Means here three ions Fe plus 2 plus Ce plus 4 gives rise Fe plus 3 plus Ce plus 3. Fe plus 2 plus 3. Here Cu plus 2 4 2 plus 3. You tell me answer. What is the correct answer? Comment on this, all of you. Yes. Tell me which is, yeah, cerium is undergo reduced, right? Reduced means addition of electrons. It added electron. Therefore, C4 to cerium plus 4 to plus 3. And here plus 2 to plus 3. Plus 2 to plus 3. So this is your what? Removal of electron. Removal of electron. So this is called your reduction. This is called your oxidation. Clear? So your answer is cerium is the answer. Clear? That is. Next one. Oxidation number of chromium in potassium dichromate. Very easy. You can take as it is C2Cr2O7. Here they are asking chromium. You can take chromium as X. Chromium as a X. Potassium 1. So how many chromiums? 2 chromiums. 2x plus potassium 2. Oxygen just now 7 into minus 2 is equal to 0. Oxygen minus 2, potassium plus 1. Okay, so your answer is what? X is equal to plus 6. And one last is, this is a B group element in the periodic table. So sixth B group element is 6 means logically we get plus 6. Clear? That's it. Next one, the ionic equation of zinc and copper. Zinc and copper. Ionic equation of zinc and copper. We'll see. See what is the correct equation of zinc and copper. Just now we see. So we'll go here. Zinc gives rise Zn plus 2. Similarly, copper plus 2 gives rise copper. Add both, we'll get the answer. Therefore, Zn plus Cu plus 2 gives rise Zn plus 2 to Cu. So where is this equation? Yes. Which option? Yes, B option is correct. So that is your answer. Clear? This is a easy one. Ionic equation of. So that is based on ionic equation concept is there, no? In a synopsis. That is here based on the ionic equations. Don't forget this. Next one, disproportionation reaction. Very important. What is disproportionation? What is comproportionation? Both are there. Okay, both are there. Disproportionately, we'll discuss that one. Disproportionation means one ion will give you two oxidation states. That is called here disproportionation. So here same element undergo both oxidation and reduction. That type of process is called what? Disproportionation. Clear? So same element giving here undergo oxidation and reduction. Clear, Shane? That is a disproportionation reaction. Disproportionation reaction. Clear? Yes. We'll see this. Or which of the following is, again, what is a disproportionation reaction? Here is an example is given. Clearly, we'll take your example. I will take you. Hydrogen peroxide you can take H2O2 gives rise, decompose water H2O plus O2. We can balance the equation. You can take 2 moles and 2 moles of water. Remaining is oxygen. See, balancing is out. Now, your oxygen state of oxygen minus 1. Here oxygen is minus 2. Here 0. So that is, this compound is minus 1 2. It become as a minus 2 and 0. So that this means breaking into 2. So one compound is giving two oxygen state. One is minus 2, another is 0. This is called here disproportionation. Proportionation. Clear? Disproportionation is this. Clear? Comproportionation. Opposite of this one. Cum proportionation means these two are giving 1. This is called here cum proportionation. Cum proportionation. This means breaking into 2 and cum means adding up 2 to 1. You can see this. Oxygen changes to minus to minus. So minus 1 to 0. So minus 1 will give you to minus 2 to 0. The type of reaction is called what? Disproportionation. Clear, friend? That's it. Next one. Oxidation number of oxygen in H2O. Just now we discussed. Oxygen, hydrogen peroxide. Hydrogen peroxide is a like this structure. This is hydrogen peroxide. Clear? Here, hydrogen plus 1, hydrogen plus 1. Clear, friend? Peroxide oxygen has minus 1 oxidation. Don't forget this one. Peroxide oxygen has minus 1 oxygen state. So here oxygen we have here mostly uh, three types of oxygens you can see. Three types of oxygens. One is called here oxide oxygen. For example, O2 is the oxygen minus. This is called oxide, right? Next one is peroxide. Peroxide means two oxygens are having bonding. So that is minus 1. That is peroxide. Peroxide one. One more is superoxide. Very important. Superoxide. Superoxide oxygen is minus 1 by 2. Exactly KO2. In KO2, oxygen is minus 1 by 2. So this is important of this. Okay. So therefore, in hydrogen peroxide, oxygen is minus 1. Minus 1. Don't forget this. Clear, students? Any doubt in this? Yes. Very good. Next one. Next one. H2O2 act as, very important it is act as a both oxidizing agent and also reducing agent. Hydrogen peroxide act as a oxidizing agent and also reducing agent. So it acts as a both, students. It acts as a both. We'll discuss in future. We have some information about this hydrogen peroxide. Then we'll just clearly. So your answer is both. So both it is act as a oxidizing agent and reducing agent. So you can say one example. In H2O2, oxygen is minus 1. So it increases to 0 and decreases to minus 2. That is increase and decrease. Just now we discussed. Increasing of oxygen shade, decreasing of oxygen shade. Therefore, it is a decomposition taking place. It undergo oxidation and reduction. Just now what I given here. See, it is undergo oxidation and reduction. Minus 1 to minus 2, addition of electron. Minus 1 to 0, removal of electron. Therefore, this undergo both oxidation and reduction. That is, it acts as a oxidizing agent and reducing agent. That is simple. Next, ionic equations show, very important. This concept is there in PCB. Ionic equations shown. So it will show here ions participating in the reaction. Only ions participating in the reaction. That is nothing here. So that is ionic equations. Only ions directly involved in the chemical change. Spectators are removed. What is meaning of this? I will give you one example. You can take here K2SO4 is given. Here we can break it 2K plus SO4 minus 2. So this one is involving, this is called spectator. This is called spectator. Spectator means it's no involved in the reaction. Similarly, KMNO4 is given. We can break it K plus MnO4 minus. This is spectator. This is ion. These ions are involving. See this question. Only ions B. Only ions are participating in the reaction. So that is remaining whatever they are here. They are not involving. They are removed. They are called spectators. Clear? That is meaning of spectator. Next one. In acidic medium, MnO4 minus changes to very important. In acidic medium, KMnO4 what happened means, see this, MnO4 minus. Just now we discussed. KMnO4 will give you MnO4 minus, spectator is removed. Then in acidic medium, it became as a Mn plus 2 ion. Mn plus 2 ion. Don't forget this. This is very easy, but we have enough more reactions mechanism. But shortcut we can understand that one. It will give you K1O4 in acidic medium will give you Mn plus 2 ions. Clear? See this. In acidic medium, K1O4 will give you Mn plus 2. Mn oxidation will changes from plus 7 to plus 2. That is important. Here plus 7, here plus 2. Difference is minus plus 5, sir. Difference is plus 5. So, the number of electrons are exchanged from MnO4 minus to Mn plus. How many electrons means? 5 electrons. That is nothing but we can write 5 Faradays. Okay, that is. Next one, oxidation number of elemental sodium. Very important. Elemental means atoms, atoms, and noble gases. And for molecules, some molecules, these all are oxygen state equal to 0 students. Very important. 0 friends. So I will explain how it will be. Be careful. For example, you can take here any atom. For example, I am taking elemental sodium. Is given elemental sodium. So it oxygen is 0. And anything, for example, potassium. Just its elemental form, it is 0. And I am taking nitrogen, elemental form, molecule form, N2, 0. And S8, 0. P4, 0. That is why KMNO4, we are going to calculate, for example, MNO4. What we are doing? This we are taking X, potassium taking plus 1, oxygen taking minus 2 is equal to 0. That is nothing but any molecule total oxygen is equal to 0. Therefore, elemental form of any element is always equal to 0. Don't forget. So, argon is given 0. Neon is given 0. Like any elemental form is always equal to 0. Your option is C. See, all free elements have oxygen equal to 0. Sodium, O2, H2, N2, anything. Don't forget. That is very important question. Next one, correct balanced equations for which is very very important. Which is correct balanced equation? So you can check it out here. How balanced atoms are there or not? For example, you can select B. Okay, we'll go for it. I am writing here again. Cl2 plus 2OH minus gives rise Cl minus plus ClO minus plus H2O is given. So we can check it out whether this equation is balanced or not. See how many Cl's here? LHS. How many Cl's? Two Cl's are there. Clear? Cl's are two. Okay. In RHS, right hand side, how many Cl's? Here is one, here is one. Yes. Here also Cl's are two. Balanced. Next, how many oxygens? Two oxygens. How many oxygens? Two oxygens. So oxygens also two. Both side oxygens also two. Clear. Next, how many hydrogens? One hydrogen is here, one hydrogen here. But here two ones are two. So here also hydrogens are two. Here also hydrogens are two. Very good. Now what is after observing all the elements, now we can see charges also. That is very important, friends. Charges. What are the charges? See, two ones are two means here two electrons are there. Here one electron, here one electron. So here also two electrons are balanced. Therefore, charges beside two electrons are there. So everything is balanced. Now we can take other example. I am taking this one in order to understand this. Either it is the balance or not, we see. See, I am writing here Cl2 plus H2O gives rise Cl plus OH minus. OH minus. Now how many Cl's here? One Cl. Here is balance? No. Here how many hydrogens? Two. How many hydrogens? So like this we can understand whether the equation is balanced or not. Thank you. This is today's class and I will go for tomorrow one more video and don't forget to subscribe my channel and please follow. Thank you very much.